Hello, my name is Randy. I am currently enrolled in an undergraduate software engineering degree program, and I kind of need to learn how to do LeetCode because they want you to. I don't know what to say. I'm not really, advanced in programming in any context, but I do want to get better. So let's get through this. Today I have chosen the Roman to integer problem. It's an easy problem, of course, companies, whatever. So the problem is we need to take Roman numeral values and just turn them into their integer counterparts. We start with these symbols I, V, X, L, C, D, and M. Each of them have a corresponding value to them, going, 1, 5, 10, 50, 100, 500, 1000. And, that's kind of the classical ones that they use. This kind of explains the Roman numerals. If you don't know how it works, I shouldn't be the one teaching you. Let's be honest. What we need to do is interpret the string that it gives us from here, the string S, and return an integer from there. The most beginner way to approach this problem would be go letter by letter and interpret from there, but then you run into some problems, especially when you get to things like this, where you get CM, which means to subtract 100 from 1000 to get 900, right? What we're going to be doing is be going letter by letter, but checking the next to see if it is a larger value. As you can tell, the larger value means implicit subtraction of the current lower value. So let's just kind of get started and explain from there. First, we're going to go ahead and just make a constant for our string length. Of course, Python doesn't have constants, but we're going to pretend like it is. There we go. We have our string length. We're going to make our index, and that will keep track of what letters we have looked at. We're going to set our solution. Of course, it's going to start out as 0, and we're going to add on top of that for each letter or letter pair that we encounter. The next thing we want to do is we need to find out how to interpret these values and kind of what we should think about them. The easiest solution that I have thought of would be to use a dictionary, one for each key, that's a symbol, and value pair. And then we can use that to compare each one. So we're going to make our dictionary, numerals, and that's going to equal this dictionary. We're going to start with I, of course, and that's going to be 1. And we're going to continue and get the rest of those into this list. All right. And with that, we have our numerals dictionary made. So we can use this to get each individual letter and say, this is the value of our current letter. Is the value of our next letter more or less than our current letter? Now, with our dictionary finished, we can get into our loop. So we're going to say, wow, the index is less than the string length, right? So meaning, as we iterate over it, we're going to go all the way to the end and just scan each letter. The only problem with this is that in cases like case 1 and case 2, we are going to actually reach this last index. And because we're doing a look ahead, it's going to reach an invalid index of this string. So the first thing we're going to write in this loop is if the index is equal to string length, string length -1 actually, because the string length will represent one more than the entire list, index-wise at least. We're going to say, hey, just add it to our solution, right? So solution plus equals numerals, because that's our dictionary. We're going to go S index, right? Which means all we're doing is going, hey, get the letter in the string S at this index, right? Put it into the key slot for this dictionary, and return the value of it. So say we start here, L. What we're going to do is we're starting at index 0. So it's, hey, out of this entire string, right, grab the 0th index, which is the L, put it into our numerals, which we find the L, we return the value, 50, and just add that to our solution. And to not get an infinite runtime type of situation going, we need to make sure to iterate our index. So index plus equals 1. So for our else if statement, what we're going to do is we're going to check our current letter and see, is it larger or equal to the letter right next to it, to the right? If so, we'll add it to the solution and go 1 forward. And that's what we're going to implement. We're going to go numerals S index is greater than or equal to numerals S index minus 1. So, plus 1. Because minus 1 would look to the left. But what we want to do is look to the right. Or I guess reversed for you guys. What we want to do is look to the letter that is on the right. So we're going to do plus 1, of course. And with this condition, what we're going to do is we're going to go the same thing. Solution plus equals numerals S index. And also iterate index. So now, let's think. We have one case left, which is the one where the following letter is a larger value than the current letter. So we don't have to write an else if or anything like that. We can just say else. What we do is we go solution plus equals numerals S index plus 1. So we add the larger number, but we have to subtract the smaller number, which, of course, is the current number. And then, because we're dealing with a pair of letters, we iterate the index by 2. And because we've handled all cases, we can just return. And with that, we can run our test cases, which have all passed, 58, 1994, and, of course, submit. And with this, we get a pretty decent result on this runtime. It is a little bit longer. I'm sure there are better ways to do this, but this is the thing that I've thought of, and it's pretty easy to kind of think about. A little bit higher on the usage, like memory usage, but still beats 90%. It's Python. I don't really care. Now, with this solution, there are a couple of important things we have to know. This dictionary here is really important when developing any kind of software or coding in general. What this does is allow expansion on what type of valid letters there are and their associated values, and whether we want to change the values of each one. Say we wanted M to equal, I don't know, 999 instead of 1,000. We can do that, and it's really easily updatable. Now, the logic down here could be a bit better implemented, I'm sure. I think this is pretty good, pretty short. A lot of this code is really easy to read when it comes to what it actually is. Pretty good self-documenting. You don't really have to say much about it. Please let me know if I could have improved this code in any way, like readability or just efficiency in total. I'm sure I could have totally abstracted this into some one-liner that just is god awful to try and read and understand, but in a context of like a shared environment where people are passing code back and forth, this would be fine. If I really wanted this to be software developer friendly, I could have added a case or used if in somewhere to make sure that we have the value. And if we don't have the value, we could return some sort of error or something. But because this is LeetCode and we are guaranteed, in this problem at least, to have, of course, our letters, as it says, S only contains the characters I, V, X, L, C, D, and M, which are, of course, the characters we're looking at. Overall, this one was pretty easy. I may challenge myself a little bit more in the future, but I just wanted to document and explain some of my thinkings when it came to this problem. Well, with that, I'm going to say thank you very much, and yeah, start coding today. Thank you.